Dr. K Mohan sir has already explained to us different stages of production of concrete like batching, mixing, transportation of concrete. Now I would like to request Dr. K Mohan sir to tell us about the aggregate. What is aggregate? Aggregate के बारे में सर हम लोगों को थोड़ा सा ब्रीफ में समझाइए.
Sure, Mr. Singh. First, I will tell you what is aggregate. Aggregates are the inert or chemically inactive materials which form the bulk of cement concrete. The aggregate is used primarily for the purpose of providing bulk to the concrete. They occupy 70 to 75% of total volume of concrete, and hence its influence is extremely important. Aggregates are generally cheaper than cement and impact greater volume stability and durability to concrete. To increase the density of the resulting mix, the aggregate is frequently used in 2 or more sizes and well graded. The most important function of the fine aggregate is to assist in producing in workability and uniformity in mixture. Physical, chemical, and thermal properties of aggregates influence the performance of. Now I will discuss about the characteristics of good aggregate. It should be hard, strong, and durable. It should be chemically inert. It should be clean, that is, it should be free from coatings of clay and silt and organic materials. It should not be soft and porous. It should be angular or cubical.
Sir, can you enlighten us about the classification of aggregate?
Very good question, Mr. Singh. I will tell you about classification of aggregates are classified in many ways. So one by one I will discuss. First, according to size. So as per size, they are classified as fine aggregate and coarse aggregate. So first I will discuss fine aggregate. Passing through a 4.7 mm ISC are defined as fine aggregate. Sand is generally considered to have a lower size limit of about 0.07 mm. Material between 0.06 mm and 0.002 mm is classified as silt. Smaller than 0.002 mm particles are called clay. The fine aggregates may be one of the following types. That is natural sand deposited by rivers, crushed sand, crushed stone sand obtained by crushing stones, crushed gravel sand obtained by crushing natural gravel. According to size, fine aggregate may be described as coarse, medium, and fine sand. Coarse sand minus 2 mm to 4.7 mm. Medium sand minus 0.425 mm to 2 mm. And fine sand minus 0.75 mm to 0.42 mm. Depending upon the particle size distribution, IS 383/1970 has divided the fine aggregate into 4 grading zones, zone 1 to zone 4. The grading zones become progressively finer from grading zone 1 to grading zone 4. Now I will discuss about coarse aggregates. Aggregates retained on 4.7 mm sieve are termed as coarse aggregates. So you can see the difference between fine and coarse aggregate. Cutoff point is 4.75 mm. Retained on 4.75 mm is coarse. Passing through 4.5 mm is fine. The coarse aggregate may be one of the following types: crushed gravel or stone obtained by gravel or hard stone, uncrushed gravel or stone resulting from the natural disintegration of rock, partially crushed gravel or stone obtained as a product of blending of the above 2 types. 8 mm size is the maximum size that could be conveniently used for concrete. The graded coarse aggregate is described by its nominal size, that is 40 mm, 20 mm, 16 mm, and 12.5 mm For example, a graded aggregate of nominal size 12.5 mm means an aggregate most of which passes the 12.5 mm ISC. Now I will discuss classification of aggregate according to source or origin. So according to source and origin, aggregates can be classified as natural aggregate and artificial aggregate. Now I'll talk about natural. These aggregates are generally obtained from natural deposits of sand and gravel or from quarries by cutting rocks. Examples: sand, gravel, crushed rock such as granite, quartzite, basalt, sandstone. Natural rocks can be classified according to their geological mode of formation, that is igneous, sedimentary, and metamorphic. Aggregates from igneous rocks are normally hard, tough, and dense. They may be acidic or basic depending upon the silica. They may be light or dark. They are most chemically active concrete aggregate. Example: quartz, granite, basalt, pumice, tuff. Aggregates from sedimentary rocks vary from soft to hard, porous to dense, and light to heavy. Examples: sandstone, limestone, shale, chert. Aggregates from metamorphic rocks show foliated structure. Examples: marble, slate, quartzite. Now I'll talk about artificial aggregates. These aggregates are man-made materials produced as a main product or an industrial byproduct. Example: broken bricks, air-cooled slag, sintered tiles. Now I'll talk about classification according to shape. So according to shape, they are classified as rounded aggregate, irregular or partly rounded aggregate, angular aggregate, flaky aggregate, and elongated aggregate. Now I will discuss one by one. First, rounded aggregate. The aggregate with rounded particles has minimum voids ranging from 32 to 30%. It gives minimum ratio of surface area to the volume, thus requiring minimum cement paste to make a good product. The only disadvantage is that the interlocking between its particles is less, and hence the development of the bond is poor, making it unsuitable for high-strength concrete and pavements. Examples: river or seashore gravels, desert, seashore, and wind-blown. Now, irregular or partly rounded aggregate. The aggregate having naturally irregular or partly rounded particles has higher percentage of voids ranging from 35 to 38%. It requires more cement paste to achieve a given workability. The interlocking between particles, though better than that obtained with the rounded aggregate, is inadequate for high strength. Example: pit sand and gravel. Now, angular aggregate. The aggregate with sharp, angular, and rough particles has a maximum percentage of voids ranging from 38 to 40%. The interlocking between the particles is good, thereby providing a good bond. The aggregate requires more cement paste to make workable concrete of high strength than that required by rounded aggregates. The angular aggregate is suitable for high strength concrete and pavements subjected to tension. Example: crushed rocks of all types. Now, flaky aggregate. An aggregate is called flaky when its least dimension, that is thickness, is less than the 3/4, that is 0.6 times of its mean dimension. Mean dimension of the aggregate is the average of the sizes through which it passes and retains. Example: laminated rocks. Now, elongated aggregate. An aggregate is said to be elongated when its greatest dimension, that is length, is greater than the 9/5, that is 1.8 times of its mean dimension. Now, I will talk about a classification according to texture. And under classification according to texture, we have glassy, that is example black flint. Then you have smooth, example charred slate marble. Then we have granular, that is example sandstone. Then we have crystalline, example basalt, granulite, some limestone, granite. Then we have honeycomb and porous, example pumice, cast. Surface texture is the property the increase of which depends upon the relative degree to which particle surfaces are polished or dull, smooth or rough. Surface texture depends on hardness, grain size, core structure of the rock, and the degree to which forces acting on the particle surface have smoothened or roughened it. Hard, dense, fine-grained materials will generally have smooth fracture surfaces. As surface smoothness increases, contact area decreases. Hence, a highly polished particle will have less bonding area with the matrix than a rough particle of the same form. Rough textured aggregate develops higher bond strength in tension than smooth texture aggregate. Now, classification according to unit area. Under that, we have normal weight aggregate, heavyweight aggregate, and then lightweight aggregate. Now, let us discuss normal weight aggregate. The aggregate has unit weight of 1520 to 1680 kg per meter. The concrete made with this type of aggregate has bulk density of 2300 to 2400 kg per meter. It is used in the manufacture of normal weight concrete. Examples: sand, gravel, crushed stone, granite, basalt, limestone, sandstone. Now, heavyweight aggregate. The aggregate has weight of more than 2100 kg per meter. The concrete made with this type of aggregate has bulk density of more than 3200 kg per meter. It is used in the manufacture of heavyweight concrete, which is used in special structure such as radiation seal. Example: magnetite, hematite, limonite, barite, heavy iron. And now, lightweight. The aggregate has unit weight less than 1120 kg per meter cube. The concrete made with this type of aggregate has bulk density of less than 1800 kg per meter. It is used in the manufacture of lightweight concrete. Example: cinder, blast furnace slag, pumice, sintered pliers.
आशा करते हैं दोस्तों आज आपको अच्छी खासी जानकारी हासिल हुई होगी। अगर आपको वीडियो पसंद आया हो लाइक और शेयर जरूर कीजिएगा। अगर हमारे YouTube चैनल पे नए हैं सब्सक्राइब करना ना भूलें, बेल आइकन को जरूर हिट कीजिएगा, जिससे आपको लेटेस्ट अपडेट नोटिफिकेशन मिलता रहेगा, हमारा मोटिवेशन बढ़ता रहेगा। वीडियो देखने के लिए बहुत बहुत धन्यवाद।